Okay, Ben, you know what to do here, yeah? A coefficients that, you know, from the system of equations, from this. So A will be minus 3, 6, minus 2, 5, okay? And you just use the theorem to evaluate. So now we go and we find beta and gamma, okay? So beta is the trace of the matrix, okay?
And gamma's the...
So beta is the trace of the matrix. The way you find the trace of the matrix is you add the diagonal elements. So minus 3 plus 5 is equal to 2. So this is greater than 0. Okay? And the gamma is just the determinant of this matrix. So it's minus 3 times 5 minus 2 times 6. So this is minus 15 plus 12. So that's minus 3. So that this is less than 0. Okay? So here we have a situation where beta is greater than 0 and gamma is less than 0. Right? Beta greater than 0. Okay, well, if gamma is less than 0, that automatically means that the equilibrium point, which is the origin in this case, okay, equilibrium point, which is the origin in this case, is a saddle, point. The origin is a saddle point.
All right, that's because this gamma is less than 0. And beta is
Right, because gamma is less than 0. So we have a behavior of a saddle point, yeah? So we get a behavior sort of like that.
Yeah.
And you could plot this and you know, find out how it behaves. But basically here we're just actually let's sketch some orbits by hand to verify the conclusion. And I showed you how to do that based on this analysis here. That's what we kind of discussed. Yeah. From that.
All right. And this is in terms of the vector field, not the, well, this would have to be a vector field, though. So, in terms of a vector field, right?
Yeah, so basically, yeah, right. You classify it and then, you know, you see which one of these does it follow. So that's the idea behind this question, is to classify the equilibrium point, whether it's a center, saddle point, stable, unstable, and then if a sink or a source is a stable spiral or an unstable spiral.